Seasonal relatives are a set of numbers that express a repeating pattern that's observed in time series data. Where do you get seasonal relatives from? You produce them from past data. That's why you see this big table of numbers presented in this particular scenario. Let's look. The director of courtesy van transportation for Livingston Medical Service suspects that demand for courtesy vans is highly seasonal. The director has 4 years of monthly data on transports made under Livingston's contract with Marion County. Oh, right. That's what I mean by big table of numbers. Here are 4 years that are history at this point, 2006 to 2009. Here's the number of van transports that were requested each and every year. Now, why is this being supplied? It says, what seasonal relatives would express the monthly fluctuation in courtesy van transports in Marion County? Let's talk about creating seasonal relatives. It is a very easy recipe, but the main ingredient is past data. Because the first thing you want to do is get a chunk of relevant past data, just like the manager did here. And using the past data, the first thing you want to do is find the historical average values each season. It's kind of like step 1. Now you might thinking, huh? That's a 4, that's a 4. Here are 4 years. Where are the seasons? Well, apparently from the manager's hypothesis, the manager believes that the seasonal fluctuation is monthly. First off, important point, and I'm saying find the historical averages of the seasons. What do you mean? Spring, summer, winter, fall? No. No, from the looks of this data and from the comments of the manager must think that it's a monthly fluctuation. Oh, meaning that there are 12 seasons, January, February, March, April, May, all the way through December. Oh, so this first step of find the historical, seasonal averages means just find the average January, find the average February, find the average March. All right, so this is the first block of work we need to do. So the first thing I'm going to do is to try to kind of get set up for this work. We need to find the average January, find the average February. I'm just drawing light yellow lines here so that my work stays organized, because it would make sense that I would put them over here to the right, these historical average values. July, August, September, October, whoops, getting a little sloppy in my line drawing, November, and there's December. I'll put a little line under December anyway. Okay. Step 1, find, for instance, the average January. What would you do? Well, you would average 151, 141, 91, and 163. I get 61.5. 161.5. That is, I'm writing X bar, that's just the average, everything that's on this row. Okay, what in the past data was the average number of van transports in February? Average 75, 76, 95, 117. I get an average of 90.75. Note that. We're going to need that later. The average in March, 52, 67. This is a 1, 103, 78. The average value is 85. Now you could stop the video and complete this list yourself if you'd like to do that, or just follow along with me. I get the average April is 74.25. I get in May, when you average these four numbers together, the average May is only 42 van transports. In June, if you average these numbers together, it continues to drop. I get the average number of van transports is 39.5. And then in July, the average number of van transports was 40.25. In August, average 39, 51, 49, and 46. I get an average of 46.25. And then in September, I get an average of 96. So van transport demand's kind of picking up there on average. In October, average those numbers together, all of a sudden I get an average of 171.25. In November, I get an average of 118 van transports. And then this drop off in December, average these numbers together, and I get an average of 42.25. Okay, this column of numbers that we've created, this is the first step towards creating that set of seasonal relatives that was asked for. These aren't the seasonal relatives by themselves. We just need them for the seasonal relatives. Oh, while we're here, it would be convenient to go ahead and do there's kind of like a second step. There's another number that will be very handy later, and that is X double bar. Find the average of the seasonal averages. If you wanted to note that down here too, find the average of the averages, basically averages. Meaning, go here, these numbers, and average them. That is known as X double bar, an average of the averages, which I did that. I got 83.92. And then we're going to need that number as well, the grand average, or the overall average. And that number has some intuition also. What that number, 83.92, is saying is that over these past 4 years of historical data, on average, there were 83.92 for courtesy van transports a month. On average, there was just shy of 84 courtesy van transports each month. Some months over those 4 years, there was substantially more than that. And some months, there was a lot less than that, but it all averages out to that number. Okay, now, why did we find these numbers when these aren't the seasonal relatives? This is not the set of numbers that reflects the fluctuation in demand for courtesy van transports. We found them because we need them to find the seasonal relatives. If you've got the note frame, this is the next page. There'll be one number for each season, and that is essentially the recipe right there. Take the average from the historical data and divide by the average of the averages. Okay, now we want to do this for Livingston Medical Services, so I'm going to draw a few lines just to keep my numbers neat, because we need to find one for January, one for February, one for March, one for April, one for May, for June, for July, for August, for September, for October, one number for November, and then squeeze a number in there for December. In each case, what we do is we get our work from the page before, and we say, what was the historical average for that season? For instance, for January, the historical average was 161.5 transports. Divide that by 83.92. I get 1.92. That 1.92, that is the seasonal relative for January. That's the seasonal relative for January. That is the single value that expresses the seasonal demand in January. Now, we're not finished with this analysis until we've produced one number for each season, which in this case is for each month. So we just continue with that pattern. The actual historical average number of van transports in February, just to take us back to the page before, was 90.75. I divide that by 83.92. Notice that the denominator is never going to change here. It does produce a different relative. I get for February a value of 1.08. Now for March, the historical average was 85. Divided by the same 83.92 means that the seasonal relative is 1.01. See the pattern? In April, 74.25, that's what we got for the actual historical average, divided by the same 83.92 is 0.88. For May, only 42 on average, divided by the same 83.92, we get 0.50. For June, wow, for June, the historical average was only 39.5 van transports that month, divided by the same 83.92, yields 0.47. For July, historical average of 40.25 divided by the same old 83.92, I get 0.48, only barely larger. In August, historical average 46.25 divided by the same old 83.92, okay, a seasonal relative of 0.55. For September, in September, the historical average was 96 van transports divided by 83.92 equals 1.14. That's the seasonal relative for September. For October, 171.25. That is the historical average divided by the same 83.92. I get 2.04. That is the seasonal relative. For November, 118 divided by 83.92. I get 1.41. And then for December, 42.25 divided by 83.92. I get 0.50 again. Okay, now, what the question asked was, what are the seasonal relatives that best express this observed fluctuation in the demand for courtesy van transports? That's the answer, so to speak. Those numbers are what we're looking for. Now, what is it? Just, okay, fine, I have a set of seasonal relatives. What did we just find? What's that supposed to mean? Well, first off, hang on to that thought. A quick check on our math. If we've stepped through those steps correctly, it doesn't matter whether it's Livingston Medical Transport or any other problem. It doesn't matter how many seasons you have, what you were doing. Once you're finished, if you add up these numbers, like the 1.92, the 1.08, the 1.01, go all the way down the list, they should add up to the number of seasons. And in our case, there are 12 seasons because we were hypothesizing that the seasonal variation was monthly. There's 12 months in the year. Now, when you do this, Like for any given problem, it might be by the time you're done totaling that it's off by a few decimal places, like above or below, and that's because you probably very naturally did some rounding in expressing the actual relatives, but it should come out to basically the number of seasons that you started with. If it doesn't, it indicates that maybe something went wrong along the way. Okay, now that was just a check on your math. That doesn't really answer the question of like, okay, great, now we have these numbers, what's this supposed to mean? Okay, you're looking at a set of seasonal relatives. What are you looking for? High numbers, and I'm referring to the relatives themselves, equal peak seasons. For instance, in general, what is their busiest month? You know, if somebody asked you that and said, well, you know, at least based on that past data, in general, what was their busiest month for courtesy van transports? Scan up and down this list. You're looking for the largest number. 1.92, oh, is beat out by 2.04. That belongs to October. So October is apparently generally their busiest month, followed pretty closely by January, because that was the 1.92. How do I know that? Because I'm looking at the relative, and those are the two highest numbers. Seasonal relatives whose values are substantially above 1 are indicating, you know, distinctly peak seasons. And you say, oh, all right. Now, there's something else that you can read from this. It has to do with low numbers. Low numbers, you know, high numbers above 1.0, low numbers, like say below 1.0, equals quiet, low seasons. So, if we were wondering when things are kind of quiet as far as courtesy van transportation in Marion County, the original context of this, we would look for the smallest numbers. See the 0.47 and the 0.48? They are definitely the smallest. Oh, and the neighboring 0.5 is pretty small. What are these? This is May, June, July. Oh, and even August, 0.55. It looks like summer is a pretty slow time for courtesy van transportation. Why? Because those months, their relatives or seasonal relatives are substantially below 1. Also followed by abruptly, you notice December? Just the month of December has a distinctly low number, although it's bracketed by somewhat higher numbers, so there seems to be a sudden dip perhaps around holiday time in courtesy van transportation. Okay, at any rate, this is a set of seasonal relatives. They express the general repeating pattern in that time series data. The really large numbers are the peak seasons. The really small numbers are the quiet times.